The NIH 3D Print Exchange is the first widely available government-sponsored repository of digital 3D models suitable for 3D printing. What is 3D printing? It's the fabrication of real physical objects through an additive manufacturing process. The control mechanism for fabrication is a specially constructed digital 3D model. It is a mainstream technology. You may not even know it, but you probably use software that directly supports it. And even if you don't have your own 3D printer, there are brick-and-mortar online vendors where you can have your model fabricated. The market as a whole is growing at more than 20% a year, and is expected to reach $4 billion next year and $11 billion in 2021. Just a year ago, the President reminded us that 3D printing has the potential to revolutionize the way we make everything. I'd like to tell you about how this disruptive technology is revolutionizing biomedical discovery at NIH. So Scott Hensley was a postdoc in the influenza lab of John Udell and Jack Bennick. They've been looking at the structure of this flu protein for more than 15 years, but no matter how much they turned it around in the screen, they were unable to see the mutations in it and how they might influence infection. When I printed the 3D structure, we immediately identified a binding groove that had been completely overlooked before. It changed the direction of research in that lab and may play a role in creating the universal flu vaccine. Clearly, new ways of visualizing scientific data can drive discovery, and at NIH, researchers are saving time and money using innovative 3D prints in the laboratory in a variety of applications that have saved hundreds of research animals and precious samples, tens of thousands of dollars, and weeks of downtime. But digital 3D models are not necessarily ready to print. Converting a digital model, such as you see on the screen, into a printable format to generate a solid object like this requires specialized software and a complicated workflow. You can take that, Brian. Pass it around. That can take over an hour, even for a skilled user. Instead, we provide online tools. This is our website that enable registered users to generate high-quality scientific 3D printable models in only minutes, simply by uploading data files that they already have or by typing in a database accession code. There is no resource like this for scientific 3D printing anywhere. Our project empowers researchers and educators by providing a trusted venue to easily create and discover community-contributed biomedical 3D print models. We also provide video tutorials to give them the skills that they need to create their own custom 3D models and prints, and we provide supplemental material for use in the classroom. As part of our project, we built a nationwide advisory team of experts and educators who are all at the forefront of 3D modeling and printing for biomedical research, treatment, and education. They provided valuable feedback in monthly group meetings and in one-on-one interviews. All of them are incredibly excited about this resource. We also cultivated a market specifically for scientific 3D prints. Whether at an NSF-sponsored STEM education fair or at the NIH Research Festival, hundreds of people spent time with us and asked serious questions about the use of 3D printing for research and education. Our outreach efforts will continue at the USA Science and Engineering Festival this spring, where we will meet thousands more. A confluence of events that we didn't know about when we started with HHS IGNITE has shown us the timeliness of this project. The NIH library will feature our site in their technology sandbox that makes 3D printers available to NIH researchers. The White House just announced a maker fair for later this year and is supporting a plan to put 3D printers in every public school. The Smithsonian and NASA have their own 3D model collections and have expressed interest in our project, and most importantly, our framework is open, scalable, and transferable, and it can be used to increase the value of and the return on these other investments. The next steps for our project are to make the website robust and secure and to continue to cultivate the national, local, and international community that we know is hungry for these models. We have an incredible team working on the NIH 3D Print Exchange. There they are. And through IGNITE, we learned to work together in ways that we never thought possible. It's opened many eyes to how we might work on future projects to drive innovation ever more quickly. Many people contribute to our project, and I want to acknowledge their assistance and advocacy, as it was truly a collaboration across many levels at NIH. We recognize the rest of the HHS IGNITE Beta cohort for their feedback and support, and especially thank Brian, Reed, and the Innovation Council, and most of all, the Secretary for sponsoring this initiative. Many doors were opened because of that. There's no way we could have gotten as far as we have without the enthusiastic support of our leadership from the highest level on down. On behalf of the team, I thank you all for this incredible opportunity and hope to have your continued support as we move forward to an exciting future for the NIH 3D Print Exchange. Thank you. That's flu. I've given you the flu. So that thing in your left hand is the little blue knobbies on the flu virus.
I'm carrying the flu right now.
You're carrying double flu. Your titer is high.
Is this infectious?
I'm just showing some other things that we've done, but I'm happy to answer your
We'd
questions.
love to collaborate with you. I mean, FDA receives 3D AutoCAD sort of the images and whatnot for us to validate, for example, prosthetics. So part of our review process to approve a prosthetic in the field is now it's a new type of submission. It's not just a drug or a device as you get a 3D print. So.
Yeah, absolutely. Actually, prosthetics is an important part. One of our advisory team works at the National Navy Bethesda, and you know they're printing prosthetics for veterans there.
Exactly.
How is it that people access the data? How difficult is that? I've heard that there's like fax 3D printers either on the way or in use. Is it as simple as calling up a fax signal and receiving it?
Well, actually, one of the high schools, believe it or not, that we're collaborating with has a scanner. You put your arm in, scans your arm, and then it prints you out a cast. And I know NASA has what they call the transporter, where they scan something and upload it to the space station for 3D printing repair parts and things. But it's not as easy as it seems, and that's where it takes more than an hour to create these things for an expert. Most people, if it's really to go mainstream, and it's on its way, it needs to be fast and easy. And the tools that we've provided and the education materials that we have, I think is going to make that much more accessible to a much larger audience.
I'm so not the biologist at the table here. I keep thinking about my friends who went to nursing school and medical school and how you use this. The bottom left segment that you're showing, I keep thinking about the insufficient number of cadavers in this country for biology and study. I mean, how do you continue to kind of develop the brain that you showed? I mean, that's where I think this is really interesting. The things that people can touch and see. I also think about all the blind scientists who must love you. Really, sincerely. I mean, for people who are visually impaired, this would be quite revolutionary in their ability to learn something that they could not see. So.
There are more and more materials coming out. The material that you have in your hand is very ceramic-like, and if you drop it, it may break. But there are rubber materials and other plastics coming online. I have a whole box back there. I'd love to show you maybe later today. So, yeah, the potential is nearly boundless.
Any other questions?